this video we will see problems related to the two-port networks. So let us solve some problems now. So in this first problem in the given circuit, okay, there is a circuit which is given here, which is a two-port network, and they are asking you to find out what is y and z parameters. So first we'll see z parameters. Let us calculate z parameters for this particular problem. Okay, now we know the equation for z parameters is v1 equals z11 i1 plus z12 i2, and we also know v2 equals z21 i1 plus z22 i2. So z22 i2. So now in this given network we need to find out what is z11. So when we say what is z11, that would be found as v1 by i1 when i2 equals 0, and z21 is also been found when i2 equals 0. So for that reason we are going to open circuit the output port. See, when current i2 equals 0, it means the current in this loop is 0. Therefore this output port or port 2 will be open. Therefore we'll write a new circuit for that. As this is open, V2 is now the voltage across this 1 by 2 ohms. Therefore I will say this is V2. Okay, now to find out Z11 we need to know the ratio V1 by I1. So how to find out that? First we will try to convert this circuit into more simplest form, and then we'll see what is V1 by I1. So for that we can see this 1 ohm and this half ohm are in series, right? 1 ohm and half ohm are in series, so they will be get added and we'll get at the end 3 by 2 ohms. Okay, so therefore the circuit would now become in this way. This is V1 I1 1 ohm 2 ohm, and this is 3 by 2 ohm. Now we see 2 ohm and 3 by 2 ohm are in parallel. Therefore 2 ohm in parallel with 3 by 2 ohm would give you 2 into 3 by 2 divided by 2 plus 3 by 2. So this would be equal to 6 by 4 plus 7. So 2 in the denominator here and 2 in the denominator gets cancelled. So you get 6 by 7 ohms. So finally I will end up in getting a circuit in this way. So this is V1 and this is I1. This is 1 ohm. This is 6 by 7 ohm. Therefore the Z11 V1 by I1 would be equal to the summation of these two resistances, so which is 1 ohm plus 6 by 7. So this will end up in getting Z11 equals 7 plus 6 is 13 by 7 ohms. So this is my Z11. Now to find out Z21. So here Z21 can be found. I'll take back the same circuit once again what I have written earlier. So I will have 1 ohm here, 2 ohm, this is 1 ohm, 1 by 2 ohm. So this is plus minus V1, 1 ohm, 2 ohm, 1 ohm, 1 by 2 ohm, and across this is what V2. Okay, and this would be the current I1. Now this current I1 is getting divided into IA and IB. Let me say current is getting divided into IA and IB. Now the current IB would now equal to, see, the current flowing through this resistance would be equal to, because these both are in series, would be equal to, total current is now I1. So I am applying current division rule here, multiplied by the opposite resistance 2 ohms divided by the total resistance of this parallel combination. So I will get 2 plus this 1 ohm plus 1 by 2 ohm is 3 by 2 ohm. So therefore I will be getting IB would be equal to 2I1 by 4 plus 3 7 by 2. So I get 2I1 by 4I1 by 7. So I get IB to be equal to 4I1 by 7. 4I1 by 7. Now what would be V2? V2 is the voltage across 1 by 2 ohms. Therefore I can easily say V2 would be equal to it would be equal to 1 by 2 times the IB, because current flowing through this 1 by 2 ohms is IB only. Therefore resistance multiplied by this current IB would give me the voltage across 1 by 2 ohms. Therefore V2 equals 1 by 2 multiplied by IB is 4I1 by 7. Therefore this will cancel 2. So I can easily say in this, finally we get V2 by I1 would be equal to 2 by 7 ohms, or I can say Z21 equals 2 by 7 ohms. So this is the solution that I got for Z21. Okay, now we got Z11 and Z21. So now we will see to get Z12 and Z22, which is equal to Z12 would be equal to V1 by I2 and Z22 would be equal to V2 by I2. This both is obtained when current I1 equals 0. Okay, so therefore if I write back the same circuit once again, so now I2 equals 0, I1 equals 0, sorry, I1 equals 0, this is 1 ohm, 2 ohm, 1 ohm, 1 by 2 ohm. Now you will see I2 will be there and this is V2. Now as I1 is 0, the current through this loop would be equal to, which is I1 equals 0. Therefore the voltage drop across this 1 ohm would be 0. There is no voltage drop across this 1 ohm. Therefore V1 would be voltage across 2 ohms only. V1 would be the voltage across the 2 ohm resistance. So this is I2 plus minus V2, 1 by 2 ohm, 1 ohm, 2 ohm. Now that 1 ohm will be removed now. Therefore V1 is the voltage across 2 ohms now. Okay, now Z22 can be easily found by reducing this circuit. So now 1 ohm is in series with 2 ohms, so 1 plus 2 would be equal to 3 ohms, and that 3 ohm is in parallel with, so I'll just write the, so I get 3 ohm here, I get 1 by 2 ohm here, and then I will have V2, and this is I2. Now V2 by I2 would now be equal to 3 ohm parallel with 1 by 2 ohms. So which is equal to 3 into 1 by 2 divided by 3 plus 1 by 2 will give me 3 by 7. Therefore Z22 would be equal to 3 by 7 ohms. Coming to finding out what is V1 by I2. Now I need to find out what is V1 by I2. So I'll take back the same circuit once again. So I have this is 2 ohms, this is 1 ohm, and there was a resistor 1 by 2 ohm parallel with this. So here this is I2, V2, and this was actually V1 across 2 ohms. Now this I2 is now again getting divided into two currents. Let me say it is IA and IB. And my job is to find out what is IB, because IB is the current flowing through 2 ohms. Therefore V1 would be equal to 2 times IB. Therefore what would be IB equals? IB equals current division rule. Total current is I2 multiplied by the opposite resistance is 1 over 2 divided by the summation of the resistance, which is 3 plus 1 over 2. So this would be IB. So if you solve it, finally what do we get is IB would be equal to this I2 divided by 7. So I'll get I2 by 7 is what? IB. So therefore V1 is now equal to 2 times IB, which is I2 by 7. Therefore Z12 would be equal to, so this is V1 by I2 equals 2 by 7 that we get. So therefore Z12 would be equal to 2 by 7 ohms. So this is the way we find out the Z parameters for any given problem. Now Y parameters. How to find Y parameters for the same circuit? So we'll take out the circuit now, the given circuit. So this is the given circuit. So this is V1, 1 ohm, 2 ohm, 1 ohm, 1 by 2 ohm, I1, I2, V2. Now Y parameters equations are what? I1 equals Y11 V1 plus Y12 V2. I2 equals Y21 V1 plus Y22 V2. So now Y11 will be obtained by I1 by V1, and similarly Y21 will be obtained by the equation I2 by V1. So this can be possible when V2 is 0. So when voltage across this is 0, when V2 is 0, it means that we are trying to create a short circuit across this terminal. Okay, a short circuit across that terminal. Therefore the circuit would be so I'm creating a short circuit across this terminal. So this is 1 ohm, 2 ohm, 1 ohm, 1 by 2 ohm. So here V2 equals 0. So this is I2 and this is V1 and I1. So this is the circuit which we get. Now if you carefully see the circuit, across this is what V2 is 0, 0. So therefore this resistance is nowhere required, because voltage across that particular node, voltage across this particular node would be equal to 0. Voltage across this resistance is 0, therefore I can easily remove this resistance. So this resistance can be easily removed. Okay, so this would be the resultant circuit that we get actually. Okay, so now to find out I1 by V1, I need to find out the total. So I can write this circuit in a much simpler way. So I'll say this is 1 ohm, this is 2 ohm, this is the resistance that I have. So therefore this would be plus minus V1, I1, 1 ohm, 2 ohm, 1 ohm, and this would be the current flowing through that 1 ohm, which is I2. This is the circuit I have. So if I want to find out what is V1 by I1, my job is to find out the simplified network of this. So what would be 2 in parallel with 2 is in parallel with 1 ohm. Therefore I get 2 into 1 by 2 plus 1, which is 2 by 3 ohms. So I get what circuit I get. This is the circuit I get. So plus minus V1, I1, 1 ohm, 2 by 3 ohm. Therefore I would say V1 by I1 in this circuit, I would say V1 by I1 I will get 1 plus 2 by 3, because they both are in series. So I will end up in getting 5 by 3 ohms. But as we are worried about Y11, therefore Y11 would be equal to I1 by V1, I1 by V1. So therefore I1 by V1 would be equal to 3 by 5 ohms. Therefore Y11 would now equal to 3 by 5 mho. We call it as mho. It is not ohm, it is mho. Therefore this is the solution for Y11. Now if I want to find out what is I2 by V1, I2 by V1, so how to find out? So if I say what is I1 equals, I1 would be equal to okay, that is fine. So we found Y11. So our job is to find out what is the Y21. Y21 is what we need to find out. So okay, to find the Y21, let me say first of all I will be getting V1 equals, so let me first write this. V1 would be equal to 5 by 3 I1 I get, right? V1 would be equal to 5 by 3 I1 I get. So now in this circuit, if you see, in this circuit I can easily apply the current division rule, where current division rule would be, because I1 is getting divided into this and this current, right? I1 would be getting divided into two different currents. If I flow the current I1 in this way, it gets divided into two different currents. So I can easily say I2 equals minus I1, because I2 is flowing in the reverse direction. Therefore minus I1 multiplied by the opposite resistance is 2, divided by summation of both the resistance, which is 2 plus 1. So therefore I will get I2 to be equal to minus 2 times I1 by 3. Okay, minus 2 times I1 by 3. So in this expression, in this I2 expression, if I substitute this I1 as V1, so what do I get? Therefore I would also say here I1 would be equal to 3 times V1 by 5. Therefore this I1 I am going to substitute here, therefore I will end up in getting I2 to be equal to minus 2 by 3 multiplied by 3 by 5 V1. Therefore I2 is equal to 3 gets cancelled, so minus 2 by 5 V1. As we know that we need to get I2 by V1, which is now equal to minus 2 by 5 mo. This is what Y21, which is equal to minus 2 by 5 mo. So I got Y11 and Y21. Now my next job is to find out what is Y12, which is equal to V1 by I1 by V2, I1 by V2 when V1 equals 0, and we also find out what is Y22, which is I2 by V2 when V1 equals 0. So for that we'll take again the circuit. Now this is the circuit. Now this will be short circuited because V1 equals 0. Therefore I will write the next circuit when V1 equals 0. So this will be short. You will have 1 ohm here now. So this is I2, 1 ohm, 2 ohm, 1 ohm, 1 by 2 ohm. This is V2 and V1 equals 0. Therefore this is I1. Now the next job is what? We need to find out what is Y12, which is I1 by V2, and Y22. So we can easily find out Y22 by finding out the equivalent resistance in this circuit. So 1 is in parallel with the 2, so I get 2 by 3 ohms I get, and that is in turn in series with 1 ohm. So 2 by 3 plus 1 would be 2 plus 3, 5 by 3 ohms. So finally I will end up in writing this circuit. 5 by 3 ohms is now parallel with 1 by 2 ohms. So this is I2, V2, 5 by 3 ohms and 1 by 2 ohms. See, this both are in parallel and that in turn in series with 1 ohm, and that is what we got, 5 by 3 ohm. Therefore V2 by I2 would be equal to 5 by 3 in parallel with 1 by 2. So what do we get when we solve it? 5 by 3 into 1 by 2 divided by 5 by 3 plus 1 by 2. So I get 5 by 6 divided by 10 plus 3 by 6. So I get 5 by 13 ohms. But I need Y22, therefore Y22 would be equal to 13 by 5 mo. 13 by 5 mo. So this is Y22. Now when I want to find out what is Y12, I need to find out what is Y12. So to find out what is Y12, my job is again to write the circuit once again. So let me write the circuit that we had earlier in this way. This is V2, I2, I1. So this was 1 ohm, 2 ohm, 1 ohm and 1 by 2 ohm. I need a ratio V2 I1 by V2. So how do we find out Y12? So that is the problem which is given here. So if you go back and see Y12, which is I1 by V2, I1 by V2. So here what we can do is to apply. So to find out I1 by V2, I'll write this circuit in such a way so I'll try to apply star delta conversion to okay, sorry, this is short. I'll try to apply the star delta conversion for this. So let us apply star delta conversion for this. So let us see what is RA equals 2 into 1 over 2 divided by 2 plus 1 over 1 plus 1 over 2 I get. So therefore RA would be equal to 2 divided by 4, 2 to the 4 plus 2 6 plus 1 7. RA I will get 2 by 7 ohms. Similarly, if I calculate RB, it is 2 into 1 by 2 into 1 by 2 plus 1 plus 1 over 2, which is equal to 4 by 7 ohms. And finally RC is equal to 1 into 1 over 1 by 2 divided by 7 by 2. 1 into 1 by 2 divided by 7 by 2, which is equal to 1 by 7 ohms. So therefore the final circuit whatever I have got is so this is short, so this is 1 ohm I1, and RB I got 4 by 7, RC I got 1 by 7, RA I got 2 by 7, and then this is I2 and this is V2. Now this 1 and 4 by 7 is in series, so I can easily write another circuit in this way. So this is I1, I2, V2, and this would be 1 ohm, sorry, not 1 ohm, 1 plus 4 by 7, 7 plus 4, 11 by 7 is what I get. So here I get 11 by 7, and here I get 2 by 7 ohms and 1 over 7 ohms. So therefore finally I can apply current division rule now. The current division rule would be equal to total current I2 would be equal to minus I1 multiplied by the opposite resistance 2 by 7 divided by the summation of the total resistance. Minus because I1 and I2, see now I2 comes and divides into two currents, IA and IB for example. So I am finding out IA. IA is nothing but I1. So I am finding out I2. Sorry sir. I am finding out I1, that would be equal to minus I2. So therefore I1 is what IA. Therefore I1 equals minus I2 total current multiplied by this opposite resistance 2 by 7 divided by the summation of resistance 2 by 7 plus 11 by 7. So therefore I will be getting I1 equals minus I2 into 2 by 7 divided by 11 plus 2, 13 by 7. So therefore I1 equals minus 2I2 by 13. 2I2 by 13. Now earlier we saw that V2 by we saw that Y22 was V2 by I2 by V2 is 13 by 5. So we saw that I2 by V2 is 13 by 5. I2 by V2 is 13 by 5, which we have got earlier. So therefore I2 would be equal to 13 by 5 into V2. 13 by 5 into V2. Therefore this I2 I will substitute in this equation. So I get I1 equals minus 2 by 13 into 13 by 5 V2. Therefore I1 by V2 is now equal to minus 2 by 5, which is nothing but Y12. So therefore Y12 equals minus 2 by 5 mho. So in this problem we got Z21 and Z12 equal. Similarly we got Y12 and Y21 are equal. So if you go back, see Y12 is minus 2 by 5 moles, Y12, and similarly we got Y21 to be equal to minus 2 by 5 moles. Y21 is minus 2 by 5 moles. Similarly we also got in terms of Z, if you see Z12 we got 2 by 7 ohms, whereas Z21 if you see we got 2 by 7 ohms. So what we are going to conclude here is as we have got Z12 equals Z21 and Y12 equals Y21, we can easily say that this is the condition for reciprocity. So therefore the network is a reciprocal network. The given network is a reciprocal network. So always in a reciprocal network we see that the Z21 impedance will be equal to Z12 and Y12 will also be equal to Y21. Okay, now let us go to the next problem. Okay, in this problem, in the next second problem, what we can see here, in the second problem we need to find out Y and Z parameters again. So in this problem what you can see is there is a dependent source which is given here, where this dependent source is a current dependent source current dependent current source which is completely dependent on the current I1. Okay, which is completely dependent on the current I1. So let us see. So let us first calculate what is Z parameters. So again, we know for Z parameters we always take the equation V1 equals Z11 I1, Z12 I2, V2 equals Z21 I1 plus Z22 I2. So we find out Z11 and Z21. We find Z11 and Z21 when current I2 equals 0. Okay, so let us write the circuit for that now. So as current I2 equals 0, so I'll just remove this branch. Now the voltage across this would be V2, and this is I1, and this is V1. Now our job is to find out what is Z11, which is V1 by I1, and also Z21, which is V2 by I1, and these both are obtained when I2 is 0, which we have written the circuit for that. Okay, now what we can do is we can apply star delta conversion for this particular network. So I'll just write it in a different manner. So that would be the easiest way to solve this, applying the star delta network. So here I'll just replacing the circuit to look in a delta format. So this is 1 ohm, this is 2 ohm. Now we'll try to write the star equivalent circuit for this. So let me say this is RA, RB and RC. So therefore here what would be RA equals, RA would be equal to 1 into 2 divided by 1 plus 2 plus 2, which is equal to 2 by 5 ohms. So which is also equal to 5 by 2 is 0.4 ohms. Similarly RB equals 1 into 2 by 1 plus 2 plus 2. I think you get that also to be equal to 0.4 ohms. Whereas RC is equal to 2 into 2 divided by 1 plus 2 plus 2, which is 4 by 5. I can easily it is 0.8 ohms. So I'll replace the circuit with these values now. Now I'll get a star network in this way. So this would be now RA, which is 0.4 ohms. This is RB, which is again 0.4 ohms. Now this is RC, which is 0.8 ohms. So this is I1, V1, and this is 3 times I1, and this is V2. Okay. Now what we can do is we can apply the KVL for this. We can apply the KVL for this particular network, or else we can also apply the current division rule, or whatever. What we can do is we can try to mark the current division. Okay, so see here, as it is 3I1, okay, as we can see this is a 3I1, the current flowing through this circuit, through this branch would be 3I1, right? So this would be 3I1. Now I1 is entering, 3I1 is leaving, therefore the current through this 0.4 ohms should be definitely 2I1. The reason is 2I1 plus I1 would be equal to total current 3I1, right? 2I1 plus I1 would be equal to the total current 3I1. Therefore, I can easily write the current through 0.4 ohms is 2I1. Okay, now I'll try to put a loop equation for this. So what will I get if I write a loop equation, KVL equation for this loop? I'll get plus V1 minus 0.4 times I1. Current is, I have assumed current is entering in this way, but this current is in an opposite direction, so I can say plus 0.4 into 2 times I1 equals 0. So therefore, if you see, I am finally end up in getting V1 and I1 ratio here now. So V1 minus 0.4 times I1 plus 0.4 into 2, 0.8 times I1 equals 0. So V1 is equal to minus 0.4 times I1 we get. 0.8 minus 0.4 is 0.4. If it goes to the right hand side, it becomes minus 0.4. Therefore, V1 by I1 equals minus 0.4. Therefore, this is Z11, which is minus 0.4 ohms. Okay, so we got what is Z11. Now our job is to write the find the Z21. V2 by I1 is what we need to find out. For that, what I'll do, I'll try to write the loop equation for this loop and see what I get. So it is minus 2 I1 into 0.4 minus 3 I1 into 0.8. So voltage across this is nothing but V2. So minus V2 equals 0, or else I can add all these things and see what do I get. Anyway, minus or plus equal to 0, right? If you take all plus also, nothing wrong in that anyway. Fine. So minus 2 into 0.4 is minus 0.8 times I1 minus 0.8 into 3 is 2.7 I1 minus V2 equals 0. Therefore, minus V2 would be equal to 2.7 plus 0.8 is 3.5, right? One second. Oh, sorry, I made a mistake here. This is 2.4 actually. 8 3s are 24. Sorry, 2.4 I1. Okay, so minus 8 minus 2.4 is minus 3.2. Therefore, 3.2 times I1. Therefore, V2 by I1 would be equal to minus 3.2. Therefore, Z21 in this problem is equal to minus 3.2 ohms. So we got Z11 and Z21. Now the next job what we need to find out is what is Z12 and what is Z22 when the current I1 equals 0. Therefore, I'll just write the circuit once again. So this is plus minus V1. Now current I1 equals 0. So this is 1 ohm, 2 ohm, 2 ohm. This is the current source 3 times I1, and this is I2 plus minus V2. Now what we need to find out here is what is Z12, which is nothing but V1 by I2, and what is Z22, which is nothing but V2 by I2, and these both are been obtained when I1 equals 0. So in this circuit, if you carefully see it, the dependent source what you have is dependent on the current I1. So this becomes 0 now because I1 is 0. Once the current source value is 0, then this current source will behave as an open circuit. Therefore, we can easily remove this current source, right? This dependent current source was dependent on I1. Now I1 is 0. Therefore, the value of this current source would be equal to 0. And we all know that when current is equal to 0, it behaves as open. Therefore, I can easily remove this dependent current source. So I'll be getting so as I1 is 0, this will be now reduced to this circuit. So therefore this is V1 now. This is 1 ohm, 2 ohm, 2 ohm, and this is I2 and V2. Now my job is to find out what is Z12, which is V1 by I2, and Z22, which is V2 by I2. Now V2 by I2 is easy to find out now, Z22, where take out the total resistance, equivalent resistance, and that is nothing but the Z22 that we get. So we know that 2 is in series with 1, 2 plus 1 is 3. Therefore Z22, which is equal to 3 ohm parallel with the 2 ohm total. Therefore we get Z22 to be equal to 3 into 2 is 6, 3 plus 2 is 5, 6 by 5 ohms is what Z22 that we get. Okay, so the next thing is Z12, how to find out Z12, V1 by I2. So for that, the current division rule is what we can apply here. So this is IB and this is IA if I take. So therefore I would say IA would be equal to the total current I2 multiplied by the opposite resistance is 2 divided by summation of the resistance. This is 3 plus 2. So IA would be equal to 2 times I2 by 5. 2 times I2 by 5. Therefore we know that voltage across 1 ohm V1 would be equal to 1 times IA, 1 times IA, because the current IA is the one which is flowing through this 1 ohm. Therefore 1 into IA would be equal to V1. Therefore V1 is now equal to 1 into 2 times I2 by 5. Therefore V1 by I2 would now equal to 2 by 5. Therefore Z12 is equal to 2 by 5, which is 0.4 ohms. 2 by 5 is 0.4 ohms. So we have ended up in finding out all the parameters, all the Z parameters for the given network. Now let us find out Y parameters. Okay, let us now find the Y parameters. Now again we will take the same circuit once again. Okay, now we know the equation for Y parameters is I1 would be equal to Y11 V1 plus Y12 V2. Similarly, I2 would be equal to y21 v1 plus y22 v2. y21 v1 equal plus y22 v2. So therefore, we now find out what is y11, which would be equal to I1 by V1. Similarly, y21 would be equal to I2 by V1 when V2 equals 0. When V2 equals 0. Therefore, when this V2 equals 0, I will write the separate circuit for that. Now, as V2 equals 0, this will be short. Two, 1 I1 and this is V1. Now, what do we can do for this? So this is I2. So I need I1 by V1 and I also need I2 by V1. Again, what we do is we'll try to apply the star delta conversion. I'll directly write the circuit because we have already applied star delta conversion for this earlier. So I'll just write the direct circuit that we get. So here I get 0.4 ohms, 0.8 ohms and 0.4 ohms. This is what I got. Okay. What can I do now? To find out, I'll just apply the voltage the node voltage analysis for this. So let me take this is VA, let me take this as VA and I'll take this as VB. Okay. Now VA, so I'll just write the equation at node 1, equation at node VA. So what do I get? I'll get VA minus V1 by 4.4 plus VA minus VB by 0.8 plus VA by 0.4 equals 0. As we know that VB is 0, VB is 0 because it is shortened. So VB equals 0. Therefore, VA by 0.4 minus V1 by 0.4 plus VA by 0.8 plus VA by 0.4 minus 1 by 0, this is 0, therefore equals 0. VA by 0.4 minus V1 by 0.4, this is 0, therefore VA by 0.8 plus VA by 0.4 equals, therefore VA into 1 by 0.4, 1 by 0.4 is it is 2.1 by 0.4 is 2.5. So it is 2.5 plus 1 divided by 0.8 is 1.25 plus 2.5 minus 2.5 times V1 equals 0. So I would be getting 2.5 plus 1.25 plus 2.5, which is 6.25 times VA minus 2.5 times V1 equals 0. So this is what I get. Okay, I think if I do in this way, the problem might become quite difficult. What I'll do is I'll try to keep the circuit as it is without applying the star delta conversion. And then we'll see what we will get. I think that would be much easier. I thought star delta conversion might become easy, but I'll keep as it is, and let us see what to do now. So here, as the voltage VP point, whatever I have written there, this point, at this point, as we can see that voltage is 0, so voltage across this 2 ohms is also now 0. So what I can do is I can remove the 2 ohms actually. I can remove the 2 ohms and I can easily write the another circuit like this. I can't remove the current source because current source cannot be here 0 here. So resistance, across resistance, if there is a 0 voltage, then there is no voltage drop. Therefore I can easily remove that resistance from the network. Now this would be the circuit that I get. Now what I will do is I will apply the node voltage equation at this node 1 and then at node 2. Okay, so if I apply node voltage equation at node 1 and 2, let me see what will happen. So at node 1 if I apply, so let me not consider this now because that made a complicated solution that we used to get. So we will go with at node 1 I1 is entering, so we normally assume everything is leaving in node voltage analysis. So at node 1 I1 is entering, so it is minus I1 plus, so the voltage at this point is V1 only, therefore V1 by 1 plus, let me take this as V2 here at this node, and this node will be V1. So therefore V1 minus V2 by 2 equals 0, right, equals 0. So now the job is very simple because V2 is 0. This V2 is nothing but voltage at this node, therefore V2 is nothing but 0. If I put V2 equals 0 here, so I will be getting the equation minus I1 plus V1 plus V1 by 2 equals 0. Therefore, minus I1 plus 1 plus 1 by 2. Okay, 1 plus 1 by 2, which is 3 by 2, which is 1.5 V1 equals 0. Therefore, 1.5 V1 equals I1. Therefore, I1 by V1 which is now equal to 1.5 more, which is nothing but my Y11. See how easily we can find out by keeping the circuit as it is. I'm sorry, on that time I did not realize that this 2 ohms can be removed because of voltage across that is 0. Okay, so I suddenly recalled that method, and then I thought, okay, why can't we do that? Okay, now the next step is we need to find out what is Y21, right? Y21. So to find out what is Y21, we will try to apply the equation at node 2. Okay, so at node 2, if I write the equation, I'll see V2 minus V1 by 2, V2 minus V1 by 2, and current is, this is leaving, so plus 3I1, and this current is entering, which is I2, so minus I2 equals 0. Minus I2 equals 0. Okay, therefore finally V2 is 0, right? We know that V2 is 0. Therefore, minus V1 by 2 plus 3I1 minus I2 equals 0. Now, if I need Y21, I need I2 by V1, right? I need I2 by V1. Now, I have I2 and V1. This I1, if I try to convert that into terms of V1, I can easily that I can get in this equation. See, I1 is 1.5 times V1. If I substitute that here, so it is minus V1 by 2 plus 3 into 1.5 V1 minus I2 equals 0. Therefore, minus 0.5 V1 plus 4.5 V1 minus I2 equals 0. 4.5 minus 0.5 is 4. So 4 V1 is equal to I2. Therefore, Y21 would be equal to I2 by V1, which is 4 more. So in this problem, we found what is Y11 and Y21. Now coming to find out what is Y12, which is equal to I1 by V2, and Y22, which is equal to I2 by V2. This can be found when we try to equate V1 equals 0. When V1 equals 0. So when V1 equals 0, what happens? I'll write that circuit now. So this is V1 equals 0, 1 ohm, 2 ohm, 2 ohm, and this is the current source 3I1. So here V1 equals 0. This is what the circuit we get. Now as V1 equals 0, this resistance what we have, where voltage across that resistance is 0 ohms, I can easily remove that resistance now. So this is what the equivalent network that we get. So for that, what we should do now is, let me write an equation. at this point it is V1, so sorry, this is V2, at this point it is V2. So if I write the equation at this point, I will be getting, so I will just assume all currents are leaving here, so I will be getting what, V2 by 2 plus, not plus, I1 is entering here, so I1, and I can also see that this 3I1 is leaving here, so it is plus 3I1, and I can see I2 is entering, so it is minus I2 equals 0. So this is the equation that we get based on the node that we have taken here. So I can easily say that I1 by V2 would be equal to, I1 by V2 would be equal to, so here if I keep the resistance as it is, now if this resistance is kept as it is, which is 1 ohm, and if I assume this is the node 1, if I say, if I write the equation at that point, anyway V1 is 0, if I assume this V1 is available here, so what do I get? I will be getting, so this is 3 branches. If I say, if I write the equation, so I will get V1 by 1 plus V1 minus V2 by 2 minus I1 equals 0. So that is what the equation I get if I assume the resistance 1 ohm is present here. Okay, anyway that makes this particular term to be equal to 0 because V1 is equal to 0. Therefore I will be ending up in getting minus V2 by 2 minus I1 equals 0. This is what I get. So therefore in this, finally what we can say is minus V2 by 2 equals I1. Therefore we know that Y12 is I1 by V2, therefore I1 by V2 would be equal to minus half. Therefore I'll be getting I1 by V2 is minus half. Therefore Y12 would be equal to minus 0.5 mho. So we got Y12. Finally, if I want to find out what is Y22, so I should go back and see this equation itself, which I have written here. Okay, so this equation, if I somehow make I1 in terms of V2, okay, so I will write this equation once again. So I get V2 by 2 plus 2 times I1 minus I2 equals 0. Therefore what we get here is, I can replace this I1 with V2 by 2. Therefore what I get is V2 by 2 plus 2 into minus V2 by 2 minus I2 equals 0. Therefore this 2 and 2 gets cancelled, so V2 by 2 minus V2 minus I2 equals 0. Therefore half minus 1 is minus half, V2 minus I2 equals 0. Therefore minus half V2 equals I2. Therefore Y22 would be equal to I2 by V2. Therefore Y22 equals minus 0.5 mho again. So this is the solution what we got for this particular problem. I hope the problems are clear to you in terms of Z and Y parameters. In my next video we'll see how to solve problems on H and T parameters.